Hello, science fans. Welcome to another fascinating journey into the wonders of our planet's weather. Today, we're diving into a weather pattern so massive it shapes the world's climate, the El Niño Southern Oscillation, or ENSO. This isn't just a local phenomenon, it's a global powerhouse that influences weather from the Americas to Europe and beyond. Picture the Pacific Ocean as a giant seesaw, with ocean temperatures and winds tipping back and forth, sometimes gently, sometimes with dramatic force. This sloshing of warm and cool water sends ripples through global weather, affecting rainfall, storms, and even the seasons we experience. ENSO has three phases: El Niño, La Niña, and neutral. Each phase brings its own unique set of weather impacts, not just to the Pacific, but to continents all around the world. El Niño, the little boy, is when the eastern Pacific heats up, warming the air and shifting weather worldwide. This phase can trigger heat waves, heavy rains, and even disrupt agriculture and fisheries. It's like cranking up the heat on one side of a pool. Energy spreads, changing wind and rain patterns everywhere. Suddenly, places that are usually dry might get drenched, while others face drought. La Niña, the little girl, is the cool phase. Cold water in the eastern Pacific, with equally powerful but opposite effects. This can mean colder winters, stronger storms, and shifts in where rain falls. Imagine dumping ice into the pool, the cold water sinks, and weather systems rearrange. Some regions may see more hurricanes, while others experience unusually dry spells. The neutral phase is when Pacific temperatures are average and the seesaw is balanced. Weather patterns become less predictable, and other climate forces can take the lead. During neutral times, other weather patterns can take the spotlight, but ENSO is always waiting in the wings, ready to tip the balance again. But El Niño and La Niña are the real headline makers, driving year-to-year climate swings. They can cause everything from devastating floods to record-breaking heat waves. Tracking ENSO helps us predict what kind of weather might be coming. Meteorologists and scientists use satellites, ocean buoys, and computer models to keep a close eye on these changes. These cycles have been shaping our climate for thousands of years, influencing harvests, migrations, and even the rise and fall of civilizations. Understanding ENSO is key to understanding global weather. It connects distant places, showing how our world is truly interconnected. It's not just science, it's a tool for forecasting the future, helping communities prepare for what's ahead and adapt to changing conditions. So, next time you hear about El Niño or La Niña, remember, it's the Pacific seesaw, and it's moving the world. The effects might be happening thousands of miles away, but they can reach your doorstep. Whether it's floods, droughts, or heat waves, ENSO is often behind the scenes, quietly steering the weather we all experience. By watching this oceanic giant, we get a head start on what's next. That's science in action, helping us understand, prepare, and thrive in a world shaped by the rhythms of the Pacific. ENSO, or the El Niño Southern Oscillation, is a climate phenomenon that unfolds in the vast expanse of the Pacific Ocean, but its influence doesn't stop there. Because our atmosphere is a global system, what happens in the Pacific can ripple out and affect places as far away as Europe, demonstrating just how interconnected our planet truly is. When ENSO shifts between its El Niño and La Niña phases, it sends out atmospheric waves, a process scientists call teleconnection. These waves travel thousands of kilometers, carrying energy and changing weather patterns as they go. Imagine tossing a rock into a still pond. The ripples spread far beyond the point of impact. ENSO works in a similar way, sending out invisible ripples through the air. One of the most important features affected by these ripples is the jet stream, a fast-moving river of air high above us that helps steer weather systems across the globe. El Niño and La Niña act like hands, pushing and pulling on the jet stream, causing it to shift north or south, and sometimes even split or meander in unusual ways. For Europe, the position of the North Atlantic jet stream is especially crucial. It determines whether mild, moist air from the Atlantic sweeps in, or if cold, dry air from Siberia plunges westward, bringing snow and icy conditions. Even though ENSO is centered thousands of kilometers away, it's a major player in these dramatic shifts, influencing European weather from afar. Of course, the connection isn't always straightforward. Other climate factors like the Arctic oscillation or pressure patterns over the Atlantic can interact with ENSO's signals and change the final outcome. That's why ENSO's impact on Europe can look different every time. sometimes bringing mild winters, other times unleashing cold snaps or storms. Still, meteorologists keep a close eye on ENSO, using its signals to help forecast what kind of winter Europe might expect. Knowing whether we're in an El Niño or La Niña phase gives us a vital clue about the months ahead, helping us prepare for what's coming. ENSO isn't the whole story, but it's a key piece of the climate puzzle that helps us understand the bigger picture. So, the next time you're deciding between a light jacket or a heavy coat in Europe, remember, a distant event in the Pacific might just be shaping your choice. Let's see what history teaches us about the powerful influence of El Niño and La Niña on Europe's weather patterns. The ENSO cycle, which includes both El Niño and La Niña, has left its mark on Europe in fascinating ways over the decades. Strong El Niño winters, such as the memorable 2015-16 season, often bring milder temperatures and wetter conditions to northern Europe, making for damp, gray days and fewer cold snaps. Meanwhile, southern Europe tends to experience drier, sunnier weather, with less rainfall than usual during these events. El Niño typically strengthens the west to east jet stream, pulling in mild Atlantic air and pushing storms across the continent. But every El Niño event is unique. Sometimes unexpected storminess or regional surprises, like sudden hail or flash floods, can still pop up. El Niño tips the odds toward a milder winter, with more green parks and lighter jackets, but it's never a guarantee. Nature always keeps us guessing. La Niña, on the other hand, often weakens the jet stream, leading to blocking patterns that can stall weather systems for days or even weeks. High pressure can get stuck over Europe, allowing cold air from the east to sweep in and chill the continent. The 2010-11 La Niña brought a famously cold, snowy winter to the UK and Western Europe, with heavy snowfalls and icy conditions that lingered for weeks. La Niña winters often start out mild, lulling people into a false sense of security, then turn sharply colder as the season progresses, catching many off guard. Southern Europe may get wetter than usual, while the north braces for sudden cold, snaps, snow, and ice, creating a dramatic contrast across the continent. By looking at past ENSO events, scientists and meteorologists can refine their forecasts and better prepare for what future winters might bring. History doesn't repeat itself exactly, but when it comes to Europe's winters, it sure does rhyme, reminding us to always expect the unexpected. As of November 2025, scientists see a moderate La Niña developing in the Pacific. Ocean temperatures are dropping, and trade winds are strengthening, classic La Niña signals. Climate models agree, La Niña will likely peak during the core winter months. This forecast is built on vast data and powerful computer simulations. While no forecast is perfect, the consensus is clear: La Niña is coming. Other factors like the polar vortex could still influence Europe's winter. But for now, meteorologists are preparing for a La Niña-driven season. It's a pivotal clue for what Europe can expect this winter. With La Niña on the horizon, Europe faces a winter of contrasts. Expect more variability. Cold snaps are more likely, especially in northern and western Europe. Early winter may start mild, but the risk of Arctic blasts rises after January. For the UK, France, Germany, and Scandinavia, be ready for a possible late winter chill. Southern Europe could see a milder, closer to average season. It's a classic La Niña pattern: cold in the north, milder in the south. One climate driver, two very different stories. The key word is variability. Swings between mild spells and sharp cold snaps. Don't let a gentle December fool you. Winter's sting may come later. This is the kind of season that keeps everyone guessing. La Niña doesn't just affect temperatures, it shapes precipitation too. Blocking patterns can shift the storm track, making northern and central Europe drier overall. But when cold air arrives, even limited moisture can mean more snow, especially in places not used to it. The UK, Low Countries, and northern Germany could see more disruptive snow events. Southern Europe and the Mediterranean may get wetter than average conditions, good news for reservoirs and crops. The Alps could see heavy snow, perfect for ski season. So, expect a continent of contrasts: drier north, wetter south, and snow where you least expect it. All of this traces back to a cooling Pacific thousands of kilometers away. That's global connection in action. These forecasts aren't just for scientists, they affect daily life. Colder snaps in the north mean higher heating bills and more strain on energy grids. Snow and ice could disrupt travel, so check forecasts and prepare your car for winter. Agriculture feels the impact too. Cold can help some crops, but harm others if freezes hit unprotected fields. Southern Europe's extra rain could boost crops and refill reservoirs. Cold weather also affects health. Watch out for slips and check on vulnerable neighbors. For winter sports fans, more snow in the Alps and Scandinavia could mean a fantastic ski season. The same weather pattern can be a challenge for some and a joy for others. Preparation is key. Insulate your home, service your heating, and stay informed. Weather shapes our lives in ways big and small. ENSO's reach is everywhere, even in your daily routine. Predicting ENSO is a global scientific effort. It starts with data over 70 buoys in the Pacific, plus satellites measuring sea temperature and height. These tools give real-time snapshots of the ocean's pulse. All this data feeds into supercomputers that simulate Earth's climate. Scientists run these models many times, tweaking starting conditions to see a range of possible futures. This ensemble approach gives us probabilities, not certainties. The result? A consensus forecast, like this winter's La Niña. Seasonal forecasting has improved dramatically, helping us plan months ahead. It's not perfect, but it's a powerful tool for governments, industries, and individuals. Science turns data into foresight. Collaboration and technology make it possible. That's how we turn Pacific ripples into European forecasts. With a variable winter ahead, preparation is your best defense. Check your home's insulation and seal up drafts to save on heating. Service your heating system before the first cold snap. Know where your water shut-off valve is in case of frozen pipes. If you drive, consider winter tires and pack an emergency kit. Blanket, flashlight, snacks, and water. Always check the weather before traveling, and don't risk journeys in severe conditions. Dress in layers and wear boots with good grip to avoid slips. Stay active, eat well, and consider a flu shot to boost your health. Look out for neighbors, especially the elderly or those with mobility issues. Offer help after snowfalls or during cold spells. Community support makes tough winters easier for everyone. Simple steps now mean fewer surprises later. Stay warm, stay safe, and stay curious.